Hi friends, this is Viswanath Chemistry faculty. Now see the answers for forensic laboratory exam. A normal bonded phase partition chromatography is used to separate vitamin C, let it be X, caffeine Y, and sodium benzoate, let it be Z, present in a soft drink. The polarity of these compounds follow the order X less than Y less than Z. The retention times of these compounds follow the order. Okay, see here, in a soft drink, three substances are there: vitamin C, caffeine, and sodium benzoate. To separate these, we used partition chromatography. Generally, chromatography means stationary phase and mobile phase. Two substances are there. The mixture which is to be separated is taken as mobile phase on a stationary phase. Here, the polarity of the substances present in the mixture is more towards that stationary phase. Retention time is also more. So polarity order is this one, means retention time also follow the same order. Hence, option B is the answer for this question. Next, in a conductometric experiment, sodium acetate is titrated with HCl solution. The type of plot obtained is, here small y represents conductance, X represents volume of HCl. So HCl is a strong acid, sodium acetate means it is a salt of weak acid and a strong base. So this sodium acetate ionizes to a small extent, whereas HCl undergoes complete ionization since it is a strong acid. Then what is the suitable graph for this titration means option D. Initially, the ionization of sodium acetate is less. Its ionization gradually increases when HCl is added to it. At a certain point, neutralization takes place. After neutralization, if we continue the adding of HCl, then conductance increases sharply because only H plus ions are present. Here HCl is a strong acid, that's why after neutralization the addition of HCl gives more amount of H plus ions, so conductance also increases sharply. Then D is the suitable option for this question. Next, the value of Kp for the reaction described by NH3 gives rise to 3/2H2 plus half N2 is 1.36 into 10 power minus 3 at 301 Kelvin. The corresponding value of Kc is universal gas constant R equal to 0.0831 liter bar mole inverse Kelvin inverse. Here Kp value is given, Kc we should calculate. So given value, this one relation is Kp equal to Kc into RT whole power delta n. Here delta n is 1. Then Kc equal to Kp divided by RT whole power delta n. Substitute Kp value R and temperature. Then we can get Kc, that is 5.44 into 10 power minus 5. What is the suitable option? Option C is the answer for this question. Next, which one of the following mixtures gives a buffer solution? So buffer solution means weak acid and it's a salt with a strong base, that is acidic buffer, or weak base and it's a salt with a strong base, that is basic buffer. So in the given four options, which one can form buffer solution means, see here, option A, 1 liter of 2 molar NH4OH plus 1 liter of 1 molar HCl. It is weak base, it is a strong acid, its molarity is more, its molarity is less. So 1 molar of this compound is neutralized by 1 molar of this compound. Then 1 molar of NH4OH is remained in the mixture. That means when this compound is neutralized with this, then we can get NH4Cl. Finally, in the mixture, we have NH4OH plus NH4Cl. So, this option can form buffer solution. This one. In the mixture, these substances are present. So, option A forms buffer solution. Next. In which of the following mixtures a precipitate is not formed? The KSP of AgCl is 10 power minus 10. Here KSP means solubility product. Now see the condition. If solubility product greater than ionic product, then precipitate is not obtained. This is very important point. We need not do any calculation for this type of questions. Simply remember this point, then we can get the answer. Solubility product greater than ionic product, precipitate is not obtained. Solubility product less than ionic product, precipitate is obtained. Now, in which option the concentration of these values, the multiplication of these values are less than this value, then that option is the answer for this question. So for this solubility product is 10 power minus 10. If we multiply this 10 power minus 6 and 10 power minus 7, 10 power minus 13, 10 power minus 13 is less than this value. So option A cannot form precipitation. Remaining three options can form precipitations. See here, 10 power minus 4, 10 power minus 4. So if we multiply 10 power minus 8, it is greater than this one. That means ionic product is greater than solubility product. Precipitate is obtained. 10 power minus 5, 10 power minus 4. Total 10 power minus 9. If we multiply this, greater than this one, precipitate is obtained. 10 power minus 6, 10 power minus 3. If we multiply, then we can get 10 power minus 9. It is also greater than this one. In case of options B, C, D, each case precipitate is obtained. In case of option A, precipitate is not obtained. Condition is this one, solubility product greater than ionic product. Next, Karl Fischer reagent was prepared by mixing. This reagent is used in titration method. So Karl Fischer reagent means iodine plus sulfur dioxide and base like pyridine dissolved in a suitable solvent, excess of solvent like methanol. This combination is called Karl Fischer reagent, I2 plus SO2 plus pyridine plus CH3OH. What is the use of this reagent means? It is used in titration, that is called Karl Fischer titration. This method is used in coulometric or volumetric titration to determine the trace amount of water in a sample. In a given sample, any small quantity of water is present that is detected by Karl Fischer reagent. This method is called Karl Fischer titration. So option B is the answer for this question. Next, in Morse argentometric titration, or it is also called Moore titration, the indicator used is option C, potassium chromate is the answer. Moore method. In this potassium chromate K2CrO4 serves as an indicator for the argentometric titration of chloride, bromide and cyanide ions. In the given compound, chloride ion is there or bromide ion or cyanide ions, then we can follow this Moore titration. Okay students.